Hey guys, welcome back to another video. We are taking a look today at statistics and all the different types of questions that have come up previously in SATs papers in the past, how to answer them, and make sure you stick around because we're also going to be taking a look at mean and negative numbers because they very often come up alongside statistics questions. But first of all, let's take a look at the first question from the 2022 paper. And this is a pictogram, very common to come up in these tests, and we need to know how to interpret them. There is something missing from this pictogram. You might already be shouting at the screen saying, where is the... But let's read it and find out because we need to know how to deal with these types of graphs. Like I said, pictogram. On Monday, 24 DVDs were sold. So on Monday, 24 DVDs were sold. How many DVDs were sold on Friday? Well, usually to answer this question, we have to use a key. That's what's missing here. There's usually a key when it comes to pictograms. And it might say one picture, in this case it's a record, is equal to a certain amount of sales. Now we don't know the answer to this because this question has gone to the next level and it wants you to work out the key yourself. How can you do that? Using the first sentence. On Monday, 24 DVDs were sold. So what we need to know is that 3 pictures of a record is equal to 24. So 3 lots of something is 24. We have to use our times table facts, or we could divide by 3. What times 3 is 24? Well, the answer is 8. And once we've done that, we've actually worked out the key to answer the question. This is a 2-step problem, really. We have to work out what each record is worth, in this case 8. Now, we cannot just put 8 and hope to get a mark. No, that's not what the question's asking. It said how many DVDs were sold on Friday. So we have 8 for each of these that we can see here. 1, 2, 3, 4, 5, and 6. 6 multiplied by 8 is 48. But, as you'll notice, we've got an extra half a record here. Now, if the picture's split in half, we have to half what the key is worth. If one whole record is worth 8, half a record is worth 4. So we're going to add on 4 to 48. And the question has an answer. It's 52. So hopefully you followed that and you can see how we'd worked out using a pictogram. For this next one, I want you to have a go yourself. This time you are given the key, but can you read and answer the question without my help? We'll go through it after. So this one's from the 2019 paper. Let's have a look. This pictogram shows the number of satellites above the Earth in 2016. So we have that labeled here. 2016 is the year. Number of satellites, and we're given a key. The question is very straightforward this time. How many satellites were above the Earth in 2016? We have to convert this picture into a number. How do we do that? We look at the key. Each circle's 1,000, so we have 1K. K is representing 1,000 sometimes, so I'm just going to use that to do my notes. We have another K here, another 1,000, so that's 2,000 because we've got 2 whole circles. Now we see how in statistics, it's very common to overlap. Like I said, we're going to talk about mean. We're going to talk about negative numbers. Here we're actually overlapping with fractions as well. Because what we have here is 1/4 of a circle. So what we have to do there, go to the key. And we want to work out 1/4 of 1,000. Again, if you've watched our video on fractions, decimals, and percentages, you know 1/4 is equal to 0.25 or 25%. So if it was out of 100, a quarter would be 25, but it's out of 1,000, so it's 10 times bigger. So a quarter of 1,000 is not 25, but it's 250. Altogether, therefore, there were 2,250 satellites above the Earth in 2016. Here's another pictogram. Again, I'm not going to say anything this time. You're going to try and solve it yourself. Then we'll go through it together afterwards, but you do have a key. Right, so let's read it. How many more children choose tiger than elephant? I always find with statistics, we can read the question, sure, but it's also good to just look at the information we're given, that data, to see if we understand it properly. So each circle is 2 children. We have the animals here and the number of children who picked it. So how many more children choose tiger than elephant? This is possibly the most common question when it comes to statistics, when we've got to compare 2 bits of data. So we've got to read 2 bits of data first and then compare them here by saying how many more. So it's tiger than elephant. So we're looking at tiger and elephant. Well, the difference here is this gap, isn't it? What is this gap worth? There's a few ways we can work this out. My favorite way to make sure is to simply work out how many chose tiger and then work out how many chose elephant and go from there. 1, 2, 3, 4, 5, 6 circles. Each circle's 2. So 12 children chose tiger. Elephant, 2, 4, and then half a circle. Half of 2 is 1. So it's 5. So we have 5 children chose elephant. How many more children chose tiger than elephant? Well, we can draw this to actually show what's going on here. If 12 children chose tiger and we have 5 children chose elephant, well, we want how much more is needed on top of 5 to get up to 12. 12 take away 5, or you can add on from 5 to get to 12. Either way, the answer is 7. Really important, we know what it means when it asked how many more. It's almost guaranteed to come up in some kind of form when it comes to the SATs paper with data to compare two numbers. So with that in mind, I've got another question that does something similar. It's not a pictogram this time, but it's the same question, how many more? So you need to harvest 2 pieces of data from the graph and then work out how many more. Have a go yourself, we'll go through it together afterwards. Okay, let's take a look. How many more year 6 children than year 2 children walk to school? So here we have how many walk to school in dark grey and how many don't in light grey. We want how many walk to school, so we're only going to look at the dark grey number. In year 6, there are, if we come across, in the real test, use a ruler to come across in a nice straight line. 120 children in year 6 walk to school. How many in year 2? You'll notice very often it doesn't actually have it labelled. We're halfway between 60 and 80. We need to know that that's 70. And now the question is, how many more walk to school in year 6? So we don't add these together. We want the difference. Again, thinking of a bar model like this, if we have a bar of 70 children in year 2 and 120 in year 6, we want the difference. What do we add to 70 to get to 120? Multiple ways to do this, but the answer is 50. That's the difference. That's how many more. Another way we can do this visually is to actually understand that each jump here is worth 10, 20, 30, 40, 50. You can see the difference right there in the graph itself. Bar charts are really useful for doing that with. So this time, same kind of thing, but instead of saying how many more, and instead of having a bar chart, it's just a table. This is still data and statistics, just shown in the table. But this time it says, what is the difference between 2 data points? Much easier to read data points on a table, but can you work out the difference? How is that different to the more than? They're very much linked, so I don't want to give anything away. Have a go at this question. I'll tell you how to solve it after. Okay, so first we need to find out how many people live in Bedford, which in this case is 82,448, and how many people live in Dover, 34,087. Cool. What is the difference? Now, funnily enough, if this is Bedford, and that's 82,000, let's just call this Bedford, and Dover is less, obviously, it's actually the same maths. Finding the difference is the same as how many more. It's both about finding that difference between 2 amounts. So we still want to know, what do we add on to Dover to get to the total for Bedford? Now, the best, most formal way to do this is to use subtraction. So we would take the amount of people in Bedford, which is the much larger amount, 82,448. And if we take off this chunk here of Dover, this bar we can see above, it's the same as just chopping this off here, taking this off, and we're left with the difference. So we're going to take away 34,087, and always, 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 always just write it out. You're allowed to write all over the question paper. It's no problem at all. Use this space accordingly. 8 take away 7 is 1. 4 take 8. We have to do some exchanging. 14 take away 8 is 6. 3 take 0 is 3. 2 take away 4. Again, we have to do some exchanging. 12 take 4 is 8. 7 take away 3 is 4. So the difference is 48,361, because that's how many more people would have to be added on to Dover to get up to the population of Bedford. Hopefully that makes sense for you guys. Next one. This is reading off the chart now. We're dipping into negative numbers, but we will look at negative numbers in more detail as well afterwards. What is the lowest temperature is the first question. And what we see here is, very common again in the SATs paper, is the same graph or the same chart. In this case, it's almost like a bar chart, but it looks different to what you might be used to, but it's still data. And we have 2 questions to answer from the same set of data. Have a go at these 2, see what you get. Okay, so what was the lowest temperature? With negative numbers, we're looking for the biggest actual number, aren't we? So -8 is bigger, is smaller than -2. So in this case, what is the lowest temperature? It's actually a match from Tuesday. We have the lowest temperature on Tuesday and the lowest temperature on Friday. Both go here. What's between -6 and -8? It's not -5. Don't go -6, -5. Remember, we're getting smaller with negative numbers. We actually go to -7. So it's important to put the negative symbol here. If we don't, we would not get the mark. And here again, look, we have what is the difference. Did you notice it? What was the difference between the highest and lowest temperatures on Wednesday? The highest temperature on Wednesday was 3. The lowest temperature on Wednesday was -5. We want the difference between 3 and -5. Now, why is it bad to draw it in this order? Because whenever we're finding the difference between two numbers and one is a negative number, it's always good to do a number line. Now think, what's the biggest number out of 3 and -5? Well, the largest number is actually 3. 3 is warmer than -5. So 3 and -5 is already labelled here. We want to know what the difference is between -5 and 3. In other words, how many jumps do we have to make to go from -5 up to 3? Well, if this is 0 in the middle, we have 3 jumps to get to 0, obviously, so that's 3. And we have 5 jumps to get to -5. So it's going to be another 5 jumps. Altogether, 5 jumps plus 3 jumps, that's a difference of 8 degrees C. Another way we could work this out if we wanted to look at the bar chart instead is to know that each one of these jumps is 1. 1, 2, 3, 4, 5, 6, 7, 8. That's it. It's as simple as that. All I've done really is draw this number line over here. It's the same answer. Okay, now we're back into the realms that we've seen before where it says show your method. So we know we're going to have to do some working out here, okay? How many children vote for strawberry? This, again, a table, loads of questions in the SATs that are just shown in table form. Probably the most simple version of a statistical representation because we're just given the data. The ice cream flavour and the number of children. The only hint you've got to do for this one off me is the total is a separate number. That's really important. Have a go, see what you get. So this is a very common type of question again, and I'm going to do this in a future video, is when we're given a total, so altogether, the answer to everything, when we add it all up, is 402. And what we've got is a missing number in the middle. So 87 plus 154 plus plus 38 plus question mark gives us 402. So the first step here is to find out what's the total for vanilla and chocolate and mint. What's the total of everything we're actually given for the number of children and what they chose. So for this, we're going to do a column addition. 87 plus 154 plus 38, like this. Little hint, when you're adding more than two numbers, you can still use column method. 7 plus 4 is going to give us 11. Plus 8 gives us 19. So we're on 19 there. 8 plus 5 is 13. Plus 3 is 16. Plus 1 is 17. And then 1 plus 1 is 2. So we're at 279. So we have 279 plus whatever strawberry is, which we don't know, equals a total of 402. This is very common in the arithmetic tests. When it's written like this, lots of you will be able to work it out. Well, what do we need to do? Well, we need to take the total, which is 402, and take away everything we're given so far, which we worked out was 279. And whatever we're left with will be this gap here that we add to 279 to get back to 402. 2 take away 9 we can't do. We can't exchange from the tens. We're going to do something here called double exchanging. Now we have 10 tens. We're going to take 1. We have 12 ones. 12 take away 9 is 3. 9 take away 7 is 2. 3 take away 2 is 1. 123 children chose strawberry. If you had time at the end of the test, what I would say is, you've got 1, 2, 3 here. Add up these 4 numbers, see if you get 402. That'd be a good way just to make sure you got it absolutely right. Okay, that would be my little technique for that one. So here, I love this one. This is a line graph. So this is showing us across the x-axis at the bottom and the y-axis across the top, going up and down. The y-axis is distance traveled, and the x-axis is time elapsed. So we start here, we have no time gone past, and we've not traveled any kilometers. And then as time goes past, we do some traveling, then we do some staying still, then we travel quicker, we travel slower. What you need to do is, between A and B, so A and B here, what actually happens? Match this kind of time frame between A and B with what goes on during it. Try and interpret this graph. What does this mean? What does a straight horizontal line mean between B and C? What's going on here? Which one of these 4 describes what's going on? Have a go, because I want you to see what you can do first, and then I'll show you how this is not actually as scary as it looks. So let's take it one step at a time. Okay, so between A and B, there are 10 minutes that have gone past. That's really important. And in those 10 minutes, how far has this person traveled? It's Dev traveling. Well, he's traveled from A to B, which means he's gone all the way up to 3 kilometers. So from A to B, he's traveled 3 kilometers and 10 minutes has gone past. So which one matches up with this for A to B? Dev cycles 3 kilometers in 10 minutes. Simple. Now the next one's really interesting. From B to C, this is again another 10 minutes, But how far does Dev travel in this 10 minutes? Well, he starts at 3 kilometers, and at the end, he stays at 3 kilometers. He does not move for these 10 minutes. So which one best represents that out of our options below? It's that Dev rests for 10 minutes. Perfect. Now let's go from C to D. We've got two options left here. Either Dev cycles 1 kilometer in 10 minutes, or Dev cycles less than 1 kilometer in 10 minutes. So is it 1 kilometer or less than 1 kilometer? Let's find out. He starts C at 3, which we've already worked out, and he ends at D. If we go across again, you could use a ruler to make sure. He goes to 4. To get from 3 to 4, that's 1 kilometer. So we can put he cycles 1 kilometer in 10 minutes. And then finally, you can see actually this from D to E, this line is less steep. So he travels less. He doesn't go as far in the 10 minutes. So that matches nicely across the bottom. Very common again in line graphs. This is pure interpretation. This is what we call interpreting a line graph. We need to know what's going on in each section and matching it to a description that tells us exactly what is happening. Next one. Oh, we're going back to that difference. Why? Because it's so common. Have a go, see what you can do. Okay, so the picture shows the masses of 8 kittens. Don't be put off by this word. You would have done it in science perhaps, but it just means weight. It's the same kind of thing. For our purposes here, it's how much it weighs. What is the difference in mass between the heaviest kitten and the lightest kitten? So 2 jobs here. We need to use place value to find the heaviest and the lightest. So 345, 275 is very low, but 255 is lower. So 255 is the lowest amount here. And the heaviest kitten is going to be in the 400s. Yes, look, it's 410. So here we have the smallest and the largest. What is the difference? We're going to use our subtraction. 0 take away 5, again, we have to do some exchanging. 10 take away 5 is 5. 0 take away 5, again, we have to exchange. 10 take away 5 is 5. 3 take away 2 is 1. The difference is 155. But why is that simple? Well, it's because it's what we said earlier. There are 2 questions based on this data, and it gets a little bit more involved and a bit more requiring your focus. I'm not going to read anything. I want you to pause this video, see if you can solve it, then I'll tell you how to do it. Okay, so the masses of the kittens are to be put into 4 groups. Write the missing number in the table. One's been done for you. All this means is that one kitten is between 400 and 449. It's this one. And I'm going to cross it out as we get rid of it so we don't count anything twice just to make sure. How many kittens are between 250 and 299? So up to 300 but not including 300. Well, how many kittens start with 200 and something? 1, 2. So we put a 2 here. Cross them out so we don't count them twice. Just going to make sure. How many kittens are in the first half of the 300s? 300 to 349. 1, 2, 3 kittens. So put a 3, cross them out, make sure we don't count them twice, and then it should be from 350 up to 399, 1, 2 kittens. Awesome. How can you check and make sure? Well, there are 8 pictures of a kitten there. 2 plus 3 is 5, plus 2 is 7, plus 1 is a total of 8. We've checked it. It seems to work. If we get time at the end, we can come back and make sure they're all in the right space. This is the meaty stuff that I mentioned at the start of the lesson. Mean. Very common, and it actually does count in statistics, a statistics question when it wants you to find out the mean. We've got some data here. It's not in a graph, but it wants you to work out what was the mean cost of the tickets. Now, if you're sat there thinking, what on earth is the mean? I want you to have a go first, and I'll explain after, because we're going to do a few questions involving the mean. So the mean is the average amount. So for example, I'm going to give you 3 here. Hayden ate 3 cream eggs. Okay. I ate 1 cream egg. I'm sensible. What can I say? And then let's say our mate down the road, Bob, he ate 26 cream eggs. Crazy. Now the mean would be how many on average did we each eat? If we were to put them all into one pile and then split them up evenly, how many would we all get? So what we do to work out the mean is we add up all of the data points. 3 plus 1 is 4, plus 26 is 30. And once we've got all the data points, we're going to divide by how many pieces of data we had, how many people were involved. In this case, there were 3 pieces of data, 3 people. So we divide them up between the 3 people equally, and that means the average is 10 cream eggs. So on average, us 3 ate 10 cream eggs. Did someone eat 10 cream eggs? No, that's why it's just an average. Okay, so an average isn't going to be exactly what everyone eats, but it's what happens when we collect everything together and share it out equally. So let's take a look here. 3 of his tickets cost £5 each. So we had a 5, a 5, and a 5. And the other ticket costs £7. Oh, maybe he's got a VIP ticket. So altogether we have 4 tickets. So what is the mean cost of the tickets? We're going to add up the total cost altogether. 5 plus 5 plus 5 plus 7 is going to get us 22. And the final step here is to divide that by how many tickets there were, which is 4. 4's into 22. Now, straight away you're thinking, that won't work. This is money. Money can go into decimals. 0, 0. £22 and 0 pence. Let's put it in, see if it helps us. 4's into 2 do not go. 4's into 22 go 5 times with 2 left over. 4's into 20 go 5 times. 4's into 0, 0. And we have there £5.50. So on average, each ticket costs £5.50. Did any of the 4 tickets actually cost £5.50? No, but it's the average per ticket if we take all the money we spent and divide it by each ticket individually. £5.50 is the average. Here's another one that we need to work out. Mean is the same thing as average. Have a go, and it's important here, it says to 1 decimal place. I'll show you how to do it after, but we need to have a go first. What's the mean maximum temperature? On the chart over there, they're all the maximum temperatures. Okay, so we're going to take all of them. We've got 5. So I know I'm going to be dividing by 5 at the end. That's going to be important. But first, I need to find the total. 8.1 plus 9.3. That gets me 17.4. Cross it out, cross it out. 17.4 plus 11.9. I'm just going to make sure with a column method. 4 plus 9 is 13. 1 plus 7 plus 1 is 9. We have 29.3. Cross it out. Then we have 29.3. Add 11.8. Again, just make sure 3 plus 8 is 11. Put decimal place in. 9 plus 1 plus 1 is 11 as well. 2 plus 1 plus 1 is 4. We're on 41.1. And finally, add on 12.4. 41.1, not 4, a 1, plus 12.4 is going to give us 5 in the tenths, decimal, 3, and 5. So we have 53.5. Now we need to divide that by 5 itself. So let's see how we can do that here. How can we take 53.5 and divide it by 5? We just use our usual bus stop method. 53.5, divide this by 5 total temperatures. Simple as that. And we're going to get 5 into 5 is 1. 5 into 3 do not go. Put the decimal place in there and exchange over the 3. 5 into 35 is 7. And look at that. It's got 1 decimal place. 10.7. 1 decimal place in this case just means there is 1 place for numbers after the decimal. It is as simple as that. Oh my gosh. This was a huge question. A 3 marker. Okay? I want you to have a go yourself. I'm going to talk it through. I'm actually not going to give you any help whatsoever. See what you can do without any help, and then I'll tell you how to answer it after. Now, the fact this is worth 3 marks tells you there's loads going on here. Okay, so let's take a look. What is the mean number, so we want the average, of people who finish the marathon per decade? So here we have the New York Marathon and each decade. What's the mean number? So let's just work out the mean first, okay, because I'm going to have to do something at the end. The mean is going to be the total of all of these added up, and then we're going to divide it by 4 because there are 4 decades. So we can actually add them right here. What I would say to you guys is write this out in the squares, okay? Line them up really carefully. But because we're adding, we can do more than 2 at once. 3 plus 2 is 5, plus nothing, plus 4 is 9 in the ones column. Now let's go to the tens column. 6 plus 3 is 9, plus 2 is 11, plus 2 gets us to 13. So exchange over the 1. Now in the hundreds column, 8 plus 9 is 17, plus 4 is 21, plus 8 is 29, plus 1 is 30. So we exchange over to the thousands now. We can put our comma in here. Thousands column, 4 plus 2 is 6, plus the 3 there is going to give us 9 in the thousands. Now the 10,000s column, 2 plus 7 is 9, plus 8 is 17, plus 5 is 23. So we can put a 3 in the 10,000s and exchange over a 2. And now finally in the 100,000s column, 1 plus 2 plus 3 is 6, plus 2 there is 8. So we have in total, over the 4 decades, 839,039 people have completed the New York Marathon. Now what we need to do is divide it by 4 because there are 4 decades. 4s into 8 go twice. 4s into 3 do not go. We have to exchange that whole 3 over. 4s into 39, that goes 9 times with 3 left over. 4s into 30 goes 7 times with 2 left over. 4s into 23 go 5 times with 3 left over. 4s into 39, again, we just did that one earlier. It's 9 times with 3 left over. 4s into 30, we can go 7 times with 2 left over. And we add another 0 in the end there. This is decimal, by the way, now. 4s into 20 is 5. So we have 209,759.75 people. Can we get 0.75 people? No. So that's not very useful. But here's where we have to look at the final part of the question. Round your answer to the nearest 100. So we want to go to the nearest 100. So here's the hundreds. We have 700s. And next to it in the tens, we look for a hint. Is the 5 closer to rounding up or rounding down? Well, it's bang in the middle. But we know if it's bang in the middle of 5, we round up. So the answer here is 209,000. And we're going to round up to the next 100. So it's not 700s. It's going to be 8 and then simply 100 at the end because we're rounding to the nearest 100. Oh my gosh. 3 steps there, 3 marks to get. You need to do every step. Every step. It's if you want to get all 3 marks. Really tricky, but a good example of how this is technically a statistics question because it's in a table, but we have to do mean, we have to do rounding if we want to get all of the marks. Amazing. So we want to finish off a little bit on those negative numbers again. We hinted at it earlier. I want you to have a look here. At midnight, how many degrees colder was Paris than Rome? Use the technique we used earlier if we have to. Negative numbers involved. Have a go. Explain what to do after. So at midnight means we're looking at this column. It's testing, can we interpret a graph? At midnight, how many degrees colder was Paris than Rome? Well, Rome was 3 degrees. Paris was -4. So it is the best practice here to do your number line. -4 is smaller because it's a colder temperature. 3 is up here, and we want the difference. How many jumps from -4 up to 3? Well, there's 4 jumps to get to 0, and there's another 3 jumps to get to 3. So all in all, 4 plus 3 is 7 degrees difference. You know what this means, guys. We're at the end of the video, and it's your turn. Which city was 6 degrees colder at midnight than at midday? Like the video, subscribe if you want more. Let us know in the comments what you want to see in the future, and give us an answer. Guys, thank you so much for watching. I'll see you next time.